All right, so now what we're going to do is talk about the relationship between moles in volume at standard temperature and pressure. And so the volume occupied by 1 mole of gas at standard temperature and pressure is known as the standard molar volume. And it is equal to 22.4. Now it's approximately 22.4, but it's pretty much 22.4. So what that means is 1 mole of a gas at standard temperature and pressure is going to be equal to 22.4 liters. And it doesn't matter what gas you have, if it's oxygen gas or nitrogen gas or carbon dioxide gas, 1 mole of it will be 22.4 liters. Just an interesting thing to think about. That's somewhere around like 7 gallons or something like that. So it's off the top of my head, not for sure if it's exactly that, but it's around 6 to 7 gallons. 1 mole of a gas is around 6 to 7 gallons or so. So there's the relationship there. 22.4 liters is going to be equal to 1 mole of gas at standard temperature and pressure. If it is not at standard temperature and pressure, then it will not be 22.4. So if you have a different temperature to different pressure, it will not be 22.4. It'll be a little different. So the following conversion factors can be written for the standard molar volume of a gas. So we know that 1 mole over 22.4 liters versus 22.4 liters over 1 mole. And so we're going to use these conversion factors to convert between volume and moles if we're at standard temperature and pressure. So even though the number of molecules will be the same for a mole at standard temperature and pressure, the mass will be different though. 1 mole of oxygen gas is 22.4 liters. 1 mole of hydrogen gas is 22.4 liters at standard temperature and pressure. But a mole of oxygen gas and a mole of hydrogen gas will have different masses. And in fact, that's why you have some gases that will float inside of other gases. So here's an example of what I am referring to. So you'll see that we have hydrogen gas and oxygen gas. Oh, it didn't have the thing there. Okay, we'll talk about that later. All right, so remember that standard temperature and pressure is 0 degrees Celsius and 1 atmosphere of pressure. So if it's not at 0 degrees Celsius, which is 273 Kelvin, and it's not at 1 atmosphere of pressure, the volume is not going to be 22.4 necessarily. It's going to be some other volume. In that situation, you would have to use PV equals nRT to calculate those things. So just keep in mind that if we are not at standard temperature and pressure, we need to use PV equals nRT. And let's go ahead and do some practice problems with it.